Next, we need to discuss what units we're going to use to measure things. This is also terminology that we use quite frequently within chemistry. So a unit is what tells somebody what the standard is for that type of measurement. For example, you may know that a meter is a measurement of length, but the meter is actually what's referred to as the Standard International Unit, or SI unit, for length, not foot, not inches. And so this is sort of what our standard measurement is and will be. For mass, that's the kilogram. For temperature, that's in Kelvin, although we really consider Celsius to sort of be an SI unit. Just so you know, we can convert between those two values with this simple equation, and that is that Kelvin is equal to your degrees Celsius plus 273.15. Time is actually in seconds, not in minutes. Something we'll talk about a lot later is the mole, and that is the standard amount or package that we'll talk about. Next comes volume. We talk about this as in liters, but just so you know, a meter cubed is the same thing as a liter. And by the way, 1 milliliter is the same thing as 1 centimeter cubed. So don't get confused with those things. We can also talk about SI units, as values, and we can predict those by what's known as a prefix. So here's what I mean by that. You can say that something is a terabyte of information. We've now got storage devices that will actually store a terabyte. Well, a terabyte is actually saying that you've got 10 to the 12th bytes of information. So that means you've got a whole lot of information in a terabyte. You might also be familiar with a gigabyte of information. And gigabytes are 10 to the 9th. That means that it's 1 followed by 9 zeros. Mega is 10 to the 6th. Notice that each of these have their own abbreviation too. Big M is sometimes hard to see, so make sure you really do capitalize that if it's a mega. Kilo is 10 to the 3rd. So a kilogram is 10 to the 3rd grams. Or a deci, whatever it is 10 to the negative 1. So deci, you think of dime, that's 1/10 of a dollar. So it would be 0.1. Centi is 1 cent. It would be a 1/100th of a dollar. So this would be like 0.01, if that's 0.1. Milli is 10 to the negative 3rd. So this is 1/1000th, or 10 to the negative 3rd. And we can keep going with this. Micro, which is this little, like a U, but it's not. It's an ampersand. It's 10 to the negative 6th. Nano, you've heard of nanochemistry or nanoscience. That's stuff that is about 10 to the negative 9th meters. Very, very small types of materials that are taking place there. Pico is 10 to the negative 12th. And if you haven't heard of this, this is called femto, which is an abbreviation of an F, and that's 10 to the minus 15th. Now, I tell you right now, you need to know what these things are. So if you haven't already, make sure you do flashcards or something to that degree that can help you identify what those things are. So one way to use these prefixes is just to say a PM, or a picometer, is 10 to the negative 12th of a meter. mg, megagram, is 10 to the 6th grams. I know that kind of sounds weird, like a megagram, but that could really, really, truly happen. Microsecond, that's what this little guy means right here, is 10 to the minus 6th of a second. And a femtometer, or FM, is 10 to the negative 15th of a meter. Now, all this is important in many different ways that we're going to use them in the future. But one of those types of measurements that we're going to use is that of density. Now, density, the SI units for this is technically kilograms over meter cubed. In other words, that's the same thing as kilograms over liter, because remember, meter cubed is the same thing as liter. But honestly, we really use more often gram over centimeter cubed, which is the same thing as gram over milliliter, right? Or if we have gases and measuring the density of a gas, often this is something that's gram over liter. So each substance has its own density. And the density of pure water is about like 1 gram per centimeter cubed, which is really, really nice because that means that we can sort of look at everything in comparison to water, and that's something called specific density or specific gravity, and we'll talk about that in just a little bit. But if the density of something is higher than that 1 gram per milliliter, generally it's going to sink to the bottom of water. And if it's lower than 1 gram per milliliter, it floats. I might show you another video of that pretty soon. Okay. So how do we convert things into terms that we can read and use those prefixes in a meaningful way? Well, here's the thing. You see this huge number right there and this huge number right there? I don't know about you all, but as soon as I look at that, I just see a bunch of zeros. They look the same to me, especially if you're reading them in a piece of type. It's also a lot of zeros to keep up with, and it's really easy to drop one off by mistake. For that reason, and many others, we actually use these in scientific notation. So instead of writing this first one here, we can write 3.6 times 10 to the 8th. In other words, all these zeros are accounted for in that 10 to the 8th. And this guy that looks sort of the same actually has another zero snuck in there. He's a 10 to the 9th. So how do we do that? Well, we got to figure out a way to do it that's sort of methodical. So here's what we do. If there's a big number, so something that's bigger than 1, let's just start with 1, then the decimal starts off, let me change colors here, as being right here, right? Well, you're going to start moving that decimal point, and every time you move it over, that's going to be a multiple of 10. So if I have it here and I move it over 1, 2, 3, 4 times to the left, then instead of writing 1, 2, 0, 0, 0, I should write 1.2 times 10 to the 4. Now I just realized that I messed up in this notes, and that should have another 0 like there, like it does above. Okay, now why is it that I didn't write 1.2000 times 10 to the 4th? Good question, and we're going to talk about that coming up in the next lesson. So don't worry about that right now. On the other hand, let's say that you've got a really small number. Let's say that we have this number that you see down here below, okay? This guy. Well, what I'm going to do is this time I'm going to take the decimal that's right here and I'm going to move it to the right. And I'm going to move it over 1, 2, 3, 4, 5 times until it's after a whole number. Because see how this guy is a non-zero? It's a real number. Well, so how I write that in scientific notation would simply be that it's 1.25 times 10 to the negative 5. If I'm moving that decimal to the right, it's negative. So think about this when you put things down. 10 to the negative means that it's less than 1. 10 to the positive means that it's more than 1. So just think about that as you move forward. And there's lots of ways to convert things. We'll talk about that moving forward. So let's try examples, okay? So let's see. This first one, and by the way, before I even start this, I would highly encourage you to attempt some of these problems and pause this video and then come back and make sure that your answers were correct, okay? So here we go. This first one, we're going to move the decimal point to the right. 1, 2, 3 times. For that reason, and this is less than 1, it should be 9.54 times 10 to the negative 3. On the other hand, our next number is very large, right? So we're going to take this decimal that should be here and move it over 1, 2, 3, 4, 5 times. So there's only one whole number in the front. So that would be 2.1 times 10 to the 5th. So see how we're doing here is really counting how many times we're moving something over. And that's not so bad. We move this up. Okay. So here we're starting with the decimal point right here. I'm going to move this over 1, 2, 3, 4, 5, 6 times. So that would mean it would be 7.65 times 10 to the 6. We said that was 6 times, right? 1, 2, 3, 4, 5, 6. Yes. This next one's a little bit trickier just because it's a little bit easy and that can trip you up sometimes, and that's okay. I'm going to move this over just 1. So this would be 1.1200 times 10 to the negative 1 in scientific notation. Again, you may question, why is it that I kept these zeros and I haven't got the other zeros? Stay tuned. And that is okay if you don't get that right now. Okay, this next number looks huge. So remember, here is my decimal point. If you want an easier way to count these, you realize that every comma is 3. So that's like 10 to the 3rd. This would be 10 to the 6th, 10 to the 9th, 10 to the 12th, and 10 to the 15th. Let's see if we actually get that. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We did. So we just moved over that decimal 10 times. So it would be 3.114, 15 times 10 to the 15th. Okay. Good job if you got those. Let's try some more. Let's try a different format. Let's try to convert these from scientific notation to our standard numbers. Again, if you can pause this video and try them yourself, I would definitely recommend that. When you see a negative, that should tell you this number is less than 1. And also realize that when you move this number back right there, that's going to take up one of those, okay? So I'm going to start with the 0 before my decimal point because when writing scientific notation or scientific numbers period, it is a good habit to put in a 0 before your decimal point because otherwise that decimal point can be lost sometimes, okay? So that -7 actually means that we should put in 6 zeros. I'll show you why in just a second. And then I'm going to put in 5, 5. Now, just to show you that that's correct, if I were to go and do this, that would be 1, 2, 3, 4, 5, 6, and there's our 7. So this is like the last of that -7, so that's like the 7th, and the zeros come in before that. So that's why I know I need 6 zeros. On the other hand, if you have something that's more than 1, you don't need to worry about that. So you just put in 4, and then the next number is your first one of this 12. So there's that. So that's now 10 to the 11th that we need to put in there. So that means we need 11 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, let's check our answers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be correct. Okay. Next we have 3.945 times 10 to the 10th. 3,945. Well, the 9, 4, and 5 were the 1, 2, and 3 of this guy. So that means that we need 7 more zeros. 1, 2, 3, 4, 5, 6, 7. Let me count this for you a different way if that's giving you any issues. See how I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how I got to that 10 right there. Okay? So let's do that a different way and check our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. So that is correct. Okay, next we have one that is 10 to the minus 4. So let's do this. 3, let me undo that. I need to start with a 0, don't I? Because I'm going to the negative 4. So I need to put in 3 zeros before this 3. How do I get that? I'm going to the 4th, and that's going to be my 4th, right? 1, 2, 3, then 3. Then we add this 0, 3, 9. Okay, let me check that. If I move this back, it would be 1, 2, 3, negative 4. So that's correct. And then again, we've got another one that's to the negative. So this is going to be my 3rd. I need to put in 0.005924. Let's check that now. I would take it back 1, 2, 3 to get my 10 to the negative 3rd. So I think we're good. Good job, guys. If this is giving you any trouble, there's thousands of examples online. So we can do more in class, but you can also find many more examples. Just, search for scientific notation examples, and you'll see lots of those out there. Thank you very much.